All right. So here are guidelines. For determining the lower class limit of the first class and class width. Okay, so first one, choosing the lower class limit of the first class. So choose the smallest observation in the data set. Or a convenient number slightly lower than the smallest observation. In the data set. As a quick example to explain that, number one, so we have a big picture. Let's say you have a category. Let's see here. Let me think of an example. Suppose your smallest, let's say you have like a list of numbers, right? It's a big table of data points. Your smallest data point is 62. So the smallest one is 62. You would create a category that's convenient. Let's say then your first class will begin at 50 or 60. Just because you have 62, which we have a category for 60. Does that make sense? Could be 50. Something that makes sense. All right. Number two. Determining the class width. If you're giving a histogram, you can see the class width by looking at the graph. It'll be just the width, literally the thickness of every rectangle. Okay, determining the class width. If you don't have that, you can calculate it with this formula in just a moment. So first thing you got to do is decide on the number of classes. Generally, we'll do an example in just a moment. I just want to have everything in one place. And then we'll start applying this. Okay. Generally, there are, or there should be, between 5 and 20 classes. The smaller the data set, the fewer classes you should have. Smaller the data set, the fewer classes you will have. Here is the formula for class width. Class width is approximately equal to the largest data value minus smallest data value divided by the number of classes. Round this up to a convenient number. Now there's a kind of a rule of thumb. So if you have like 2 decimal points, you'll go down to the third. I'll show you what I mean. So let's say let's suppose the largest and smallest is equal to 322.61 and smallest equal to 65. The class width would equal to 322.61 minus 65. Now they have to give you the classes, or you'd have to have determined that before this point. So let's say they told us it was 11, right? Just for this example, the book. I get about approximately 23.419, so I'll stop it right here. There's no rush. Okay, let's see. I think there might be one or two more things.
We just leave it as is and round it up to 0.42.
Round to 0.419. Usually, if you have two decimal points, yeah, two here, you want to round the one after. But we'll do some of that in a second. Wait a sec before we write some more. Everyone cool on this first page? All right. So I think that's most of the stuff for 2-2, and then in just a moment, we'll do the actual problems. Then we'll do 2-3. Okay. The 2-3 thing, the main thing is the stem and leaf plot, which is pretty easy. So step 1, the stem of the data value will consist of the digits to the left of the rightmost digit. The leaf of the data value will be the rightmost digit. Yeah, step 2. Write the stems in a vertical column in increasing order. Draw a vertical line to the right of the stems. This is the beginning of 2.3, by the way. Once you see it, it's going to be super easy. It's just the definitions are a little wordy. Okay. Write each leaf corresponding to the stems. To the right of the vertical line. Final step. Within each stem, rearrange the leaves in ascending order. Title the plot and include a legend. To indicate what the values represent. All right. Keep doing that. All right, we might need to add some more, but we'll see. Let's go look at the homework before I run out of time. Sorry. Just a moment. So if you have like, let's say a bunch of data points that are in tens place, say we have a bunch of 20s, 30s, 40s, 50s. Step one is telling you the left, the rightmost digit would be the tens place, right? Yeah, but let's say you have 23. 2 would be leftmost from the right most digit. Go the left from the rightmost. Now, that's going to be the step. The tens place was its step. You create a bunch of leaves for the ones place. Essentially, that's what we're doing. We're going to do that in just a moment. So if you have like 22, 23, 24, you'd have a 2, and then the leaves would be 3, 4, or 2, 3, 4. 2 representing 22, 3 representing 23. You'll draw that up. That's all this is really saying. If you have hundreds, if they're all in the hundreds place, you would look at the digits to the left to the rightmost. Okay. So this is trying to cover every scenario. That's why there's so many words. But once you see it, it's very basic. Anyway, I'll switch back to this in a moment. Well, I'll wait a few more minutes. Sorry. It's fine. Let's look at our homework. Let me change my settings here. Okay. Oh my gosh. whatever. So go to your homework, 2.2. There's technically another formula here, if you think about it. Q says the class width is the difference between the second and lower classes. So if they already give you the lower classes, you subtract them. Do right next to each other. You get the width automatically. So that's one way to get a width, or another way. Number 3. If I can see anything. Okay, here we go. This is better. Just gonna go straight in there. Mine's being weird for some reason. Okay. So this, I would get a little excited on this type of question. What is the shape of the distribution? This is a histogram. Notice how the width is all the same. Right, so you can see the class width like that. Check out the distance. Every category has the same distance. So what this is representing is a collection of data points. We're just all it's doing is organizing your data. So there's, I don't know how much that is, if they give you a line, but there's this many values between 0 and 3. There's this many values between 3 and 6. So the width is 3 each time. Okay. If you see the tail going towards the right, that is considered to be right skewed data. Okay. It's not where the center is, it's where the tail is. It's skewed right, it's dependent on the tail. If the curve or the histogram is centered, then you would say that is a symmetric and uniform or bell-shaped, depending on the type. Like this guy is centered. And it has a bell form, so you can draw a bell curve right above it. Number 5, you zoom in a bit. For 5, the bottom part's cut up. There we go. So here they rolled a bunch of a pair of dice, and they counted how many times each number appeared. So okay, 2 appeared about 1 time, and maybe 2 times. Double 6 is 12, that was about once. So the height is the frequency of each category. How many times did I get a 7? Well, that's the most easiest number to roll. So it's going to be over 21. So it's centered here because that's has a high probability. Okay. So when they ask you a question, how many times did we observe a 9 when it's tossed? Go to the category 9, see how many times it appeared. It appeared about 9 times. That's how you're doing. So that's how you read these. Height tells you the frequency. Width is just the frequency of each class. Okay. Then they'll tell you here how many more 7s were observed than 12. We'll just add them up, right? Find out the difference. Nothing insane. Percentage is related to what we talked about last time, the cumulative frequency or relative frequency, I'm sorry. So what you would do is figure out, okay, how many times did 9 appear? Said about 9 times, right? And the question said they rolled up the dice how many times? Two fair dice were thrown 100 times. So if it appeared 9 times, then percentage-wise, that would be what? 9 out of 100. So 9%, right? So just like we did last time, we didn't have a perfect 100, we just had a total. We said divide your frequency by the total, that's your relative frequency. It's the same deal. Divide your total for that category, divide by total. Just change it to percent. That's the only difference for relative. So relative is the same thing, just change it to percent. Okay. It's bell-shaped, etc. Okay. Number 6. So check this guy out. Let me zoom in again. These are IQ scores. I believe 100 is about, I think about an average score for a person. Which kind of makes you think about it, right? The center is an average intelligence. Everything above that would be above average. So everybody over here is smart, high IQ. Everyone over here is not. That's a huge population that's below average. But when you run into it, makes sense. A ton of them. Right? What we hear is visibility. What we hear is genius level game. Right? So there's always it's opposite. But it makes sense, right? Half the population would be below average because IQ fits a bell type of shape. Does that make sense? So there should be a ton. Anyway, so how many students were sampled? Well, how would you find the total, right? We know we have categories and we have frequencies. What would you do? What would you add up? Yeah. How many people appeared within 60 to 70? Right? 2. 70, 80, 2. Add these up, you'll have your total. Nice. Because we said the height is a frequency. That's how many data points appeared in that category, that class. I don't know what that is. I'm not gonna waste my time adding. I believe that in you guys, you can add these together, right? Let's move on to the next part. It's 200. Okay, determine the class width. Can you see the width? What is the class width here? The thickness of this is our width. It's just half, right? Nothing you say. Should be 10. I hope it's 10. If not, I'm down here somewhere, right? Okay. Identify the classes and their frequencies. Choose the correct answer below. Okay. So here they're just grouping each class and how many times data points appeared in that spot. So which one would you choose? Yeah. C makes no sense. Can be C. Looks like it might be A. That has your category and how many times you appear. This is a little different. So this being more using limits. Let's check. Let's find out. That's incorrect. So why is that? All classes should have IQ scores unique only to one class. So do you see the problem? right? I can't use 72 times. See that? I cannot have it overlapping. They should be separate. That's what they said in the notes earlier. We said choose something that's convenient. The one below. We just kind of shift everything down by one. That way we won't repeat ourselves. Which one has the highest frequency? Yeah, looks like. Let's see. Yep. And in terms of frequencies, the highest one tends to be your average. Okay. When you have frequency distributions, the highest category will be the average. That's what we're saying. The average IQ is around 100 or so. Okay. How many parts do they have? So here is just the lowest. Looks like the super intelligent person. There's not that many of them, right? Be 150 to 160. Would we choose A or D?
Okay.
Yeah, I think it's A. That'll be when you're doing this on your own. If you get one wrong, you can repeat the whole question, but you have to go through all of them. So if you want to, let's say, fix part B, you'd have to finish the whole thing, then restart. So that's up to you if you want to do that, but you do get partial credit. If you lose like 1 point here, it's up to you. If you have the time, go for it. So percentage, how do we calculate percentage in the last question? Let's say it says at least 130. What does at least mean? Yeah, it means 130 or higher. So at least means X is greater than, oops, greater than or equal to 130. So that includes all these guys here, right? So now back to the original question, how can we calculate percentage? Yeah, I think it's gonna be 12 out of 200. So you add up the total, whatever we're talking about, divided by total everything. But was this is not just one category, it's everyone above 130, so 48. 7 plus 4 plus 1 is 12, divided by total, which we said was 200. People measured what they said. I don't remember. Yeah, 200. So what is 130? I'm sorry, 12 divided by 200. 6%. Yep. Okay, last part for this question. Did any students have an IQ of 166? I don't think so, right? Why not?
Because it only goes to IQs were 160.
Yeah, the category ends right at 160. Makes sense to me. Think we're see how much time I have left. I have 5 minutes left, so I'll let you work on some homework and let me do some roll here.